All right, period 9. Yo, we're going to just finish this problem because that just makes more sense anyway. So here we go. We were in the middle of trying to prove that n squared was less than 2 to the n. We did some experimentation. We found out that this is true starting at 5, and we want to prove that it's true for all numbers after that. This is the kind of proof that you can only do by induction. And remember, we checked our base case and n was 5, and then we supposed that k squared was less than 2 to the k, and what we want to show is that k plus 1 squared is less than 2 to the k plus 1. So we kind of rewrote this proof statement in several equivalent forms until I got it down to this thing in the red box. This thing in the red box is what I wanted to prove, and the brilliant observation that we had just as the bell was ringing was that if I know that k squared is less than 2 to the k, and I want to prove that k squared plus 2k plus 1 over 2 is less than 2 to the k, then what I wish were true is that k squared plus 2k plus 1 over 2 was less than k squared. I wish this were true because I can take this together with this statement and it'll make this statement. Okay, so now I can just focus my attention on proving this. How can I prove this? Well, we're just going to kind of like mess with this, right? Bring the 2 over to the other side. So this is, this says k squared plus 2k plus 1 is less than 2k squared. And now what should we do? What should we do, people sitting in the room? Move everything over to one side. Yeah, that's right. So if I move everything over to one side, then that's actually just like k squared minus 2k minus 1. And I have to somehow prove that k squared minus 2k minus 1 is positive. Is that true? The people in the room choose to remain anonymous. No, what does it talk?
Wait, can't you like do induction on that kind of?
Oh, he wants to do a whole induction proof all over again to prove that this statement is true. What can we do?
Or just like do the graph.
Yeah, we could just like try some like random crap, like draw this function, make a graph of it, you know, blah blah blah. Like factor, like make a sine term. It doesn't factor, which is kind of unfortunate. By the way, what about when k is like 0? Is it true? Is that a problem? Is that a problem, Yanni? Is that a problem? Why? Yeah, I only need this. This doesn't need to be true for all k. It just needs to be true for k greater than or equal to 5. It seems kind of obvious that it's true for k greater than or equal to 5, right? All right, there's one more move. What we might do now is like complete the square. So this is actually like k squared minus 2k. I guess that's like, that would be like plus 1 minus 2 or something, right? So really what I need to do is I need to show that k minus 1 squared is greater than 2. Is that true? K is bigger than 5, is that true? Yeah, that's definitely true. Alright, so I'm happy now because I have essentially reduced my wish down to something that's like really, really easy. So now I feel like this is going to work. Alright? Daniel Chen, you okay? Yeah, okay. He's not anonymous anymore, it's Daniel Chen. Alright, so now we have to actually do it. Because this was just like a jumble of like conjecture and guesswork and scratch and like screwing around and blah, blah, blah. So now we're going to get to the actual proof. What is the actual proof? Well, I'm going to basically use the inspiration which I learned over here in the screwing around phase to like write it out all nice and properly. Alright, so basically what I'm going to do is I'm going to prove the wish first, and then I'm going to take the wish and I'm going to take the inductive hypothesis and I'm going to put them together. Make sense? Of course it does. Okay, how do I prove the wish? What does the whole entire wish depend on?
2 is less than k minus 1 squared.
Right, but it depends on using what? What do I know? What's the only thing I know? That k is greater than or equal to 5. So I start with that. I'm going to start with, can you take a peek and make sure we're in frame? I'm going to start with k greater than 4, and from, you don't have to touch it, it's okay, is it okay? If we're going to start with k greater than 4, and using just k greater than 4, I'm going to prove the wish. Okay, what should we do first? He's mumbling, so I guess I'll just do it. I know, the only thing I know is that k is greater than 4, so I'll just subtract 1. If k is greater than 4, then k minus 1 has to be greater than 3. Yeah. Now what? Now we can square both sides. So if we square both sides, we get k minus 1 squared is greater than 9. Okay, now we do this really like weird step, which feels weird, but is in fact totally legitimate and valid. We say, all right, if k minus 1 squared is greater than 9, then it's certainly true that that k minus 1 squared is greater than 2. Because if you're greater than 9, then you're also bigger than 2. But I want it to be bigger than 2 because I want all my algebra to like work out nicely and stuff, right? And now I do this whole sequence of strange moves, which I never would have thought of, except for the fact that I kind of did the whole problem already. So, what should I do? What do I do now? Just like do all that backwards, he says, yeah. So that's like k squared minus 2k plus 1, that's supposed to be greater than 2. And then I guess I'm supposed to like move everything over to one side. So really that says k squared minus 2k minus 1 is greater than 0. Now what do I do? I guess I like add, what should we do now?
Just do case.
Oh yeah, I want to move some things over, right? Oh yeah, actually I want this to say k squared is bigger than 2k plus 1. That's kind of what I want, right? Now, add k squared to both sides. So that's 2k squared is greater than k squared plus 2k plus 1. And if I divide by 2, now that says that k squared is greater than k squared plus 2k plus 1 over 2. So after like 8 or 9 pretty tedious steps, but it's like super airtight and like super just, you know, satisfyingly perfect, I have now proved my wish. I have proved that k squared plus 2k plus 1 over 2 is less than k squared. That was my wish, and I proved it, using only the fact that k is greater than 4. Why did I want this wish anyway? I wanted this wish because I also know my inductive hypothesis. My inductive hypothesis is that k squared is less than 2 to the k. So if this is true, and this is true, then these two facts can be combined, and I now know that k squared plus 2k plus 1 over 2 is less than k squared, which is in turn less than 2 to the k. And what I really care about is just the first and the second one. So k squared plus 2 plus 1 over 2 is less than 2 to the k. And now looking back, notice I've now proved that thing that I called, that thing that I said, the thing in the red box that I wanted to prove, I've now proved that. And why did I want to prove that thing in the red box? We still have a couple more little things to do. Multiply both sides by 2, he says. So we get k squared plus 2k plus 1 is less than 2 times 2 to the k. And this just is k plus 1 squared is less than 2 to the k plus 1. And now this completes the inductive step. So what have we really done here? What we did is we showed that it was true. We showed that 5 squared is less than 2 to the 5th by brute force. And we showed that whenever k squared is less than 2 to the k, then it must be true for the next number, that k plus 1 squared is less than 2 to the k plus 1. So whenever this inequality is true for k, it's true for the next number k plus 1. So assuming that k is greater than 4. So by the principle of mathematical induction, for any n greater than 4, this must be true that n squared is less than 2 to the n. Get it? Of course you do. Good. Bye. That was only 10 minutes.